If one of the zeros of a quadratic polynomial is of the form x square plus ax plus b is the negative of the other, right? So let the roots be alpha and beta. So it is given that one of the roots is the negative of the other. So beta is equal to minus alpha. No, it is not a conjugate thing. So if one of the root is 2, the other root can be minus 2. Right? So this kind of scenarios we see in cases like x square minus 4 equals to 0. So x square equals to 4. X is plus 2 comma minus 2. Right? So this says it has no linear term. Right? Like this. But I mean, we can just prove this as well. So we have x square plus ax plus b. Right? So what will be the sum of roots? Alpha plus beta. Alpha plus beta will be minus a upon 1. If you look at this equation, not that general equation. Right? So it will be minus b upon a. So b here is a. So minus a upon 1 or minus a. And we know that, so from this equation, we can say alpha plus beta is 0, which means a is equal to 0. So the value of a is 0. So then the equation becomes x square plus b. Now we need to find the value of b. So we'll use the product of roots. So alpha beta is equal to c upon e, but here c is b. So it will be b upon 1 or b. So what is the value of alpha beta? Alpha beta will be minus alpha square, because alpha is alpha and beta is minus alpha. So if you multiply both of them, you'll get minus alpha square. So you'll get b as minus alpha square. Well, so this alpha, no matter what the value is, alpha square will always be positive. That means b is negative. So it has no linear term. So the linear term has vanished because a is 0 and constant term is negative, which we have already seen. Any question? Okay. If alpha and beta are the zeros of the polynomial x square plus px plus q, then the polynomial having 1 upon alpha and 1 upon beta as its zeros are. Okay, so it is given that alpha is a root of this equation and beta is also a root of this equation. So you just have to find the polynomial which has 1 upon alpha and 1 upon beta as its root. So for such equations, you just assume let this be y. So let y be 1 upon alpha or y upon beta, whatever, 1 upon beta, right? So then you can write alpha as 1 upon y. And we know that alpha is a root of this equation x square plus px plus q. So I can write alpha square, or I can write f of alpha equals to 0, right? Which implies instead of x, if I substitute alpha, I'll get 0. So x square plus p alpha plus q is equal to 0. Now I also know that alpha is 1 upon y, right? So I'll just substitute 1 upon y here. So 1 upon y square plus p upon y plus q equals to 0. Now I'll multiply both sides by y square to make sure this variable is not in the denominator. So I'll get 1 plus py plus qy square is equal to 0. So this is the equation. So qy square plus py plus 1 equals to 0 is the equation whose roots are 1 upon alpha and 1 upon beta. But this is f of y. I can convert it to f of x by just substituting y as x. So because they are variable names, so you can name it like z as well. You can name it w as well, right? So you can write q x square plus px plus 1. Okay, is this clear? Next, we have if alpha and beta are the zeros of polynomial f of x equals to x square minus p times x plus 1 minus c, then alpha plus 1 times beta plus 1 is equal to. So first of all, we need to simplify this or expand this. See, whenever you see such thing, you can, understand that we can write this in the form of alpha plus beta and alpha beta. And we can use the polynomial to find the value of alpha plus beta and alpha beta. Right, so just expand this polynomial to get some terms in the form of alpha plus beta and alpha beta, and then we'll use this equation to get that value. So this will be equal to alpha times beta plus 1 plus 1 times beta plus 1. So Puneet, you're saying something? I'm just expanding this. So this is equal to alpha times beta plus 1 plus 1 times beta plus 1. If I just expand this part. Right? So this will be alpha beta plus beta plus 1. So this is equivalent to alpha plus beta plus alpha beta plus 1. Right? Alpha plus beta, we know it is minus b upon a. But here, I mean, we have to find that minus b upon a. So this is not minus b. Minus b is, or b is the coefficient of x. But this is the coefficient of x plus 1. Right? P. So we have to first simplify this. So x square minus px minus p minus c. So this is the constant term. So I mean, this is the constant term and this is your b. So you can write alpha plus beta is minus b upon a, which is minus of minus p upon 1. Right? So alpha plus beta is p and alpha beta is c upon a, which will be equal to minus p minus c upon 1, which is equal to minus p minus c. Right? So if you write the value of alpha plus beta, so alpha plus beta is p and alpha beta is minus p minus c and then plus 1. So p and p gets cancelled. We are left with 1 minus c. Okay, any doubt? If zeros of the polynomial, this particular polynomial are in AP, then I mean AP we have not studied so far, but we have discussed one of the properties of AP. Say AP is when there is constant increase. Say 2, 4, 6, 8, 10, or say 3, 5, 7, 9, 11. So it is increasing by 3. So it can also increase by any number. Say 5, 9, 13, 17, 21, and so on. Right? So, I mean, no matter what the AP is, one thing that you'll notice is that the middle term is the average of the first two terms. Right? Say if you take the sum of this two, 6 plus 2 upon 2. So average of 2 and 6 will give you 4. Average of 7 and 3 will give you 5. Average of 13 and 5 will give you 9. Similarly, average of 8 and 4 will give you 6. Average of 9 and 5 will give you 7. And average of 17 and 9 will give you 13. Right? So this is the property of an AP. So similarly, this is a cubic polynomial. So it says that the zeros of the polynomial are in AP. So if you take these zeros, so alpha plus beta plus gamma, you know this is equal to minus b upon a. So here minus b is 3p, right? So minus of minus 3p. So that will be 3p, right? And since alpha, beta, gamma are in AP, so we can write beta is equal to average of alpha and gamma, what we have already seen. So alpha plus gamma upon 2. So alpha plus gamma will be equal to 2 beta. So instead of alpha plus gamma, I can just write 2 beta. So 2 beta plus beta is equal to 3p. So beta will be equal to p, right? And you know that beta is a root, which means if you substitute beta here, this will be equivalent to 0. So instead of beta, I'll just write p, right? So I'll just substitute p here. So I'll get p cube minus 3p cube plus qp minus r is equal to 0. So p cube minus 3p cube is equal to minus 2p cube plus qp minus r is equal to 0. So if I take this to the right hand side, we'll get 2p cube equals to qp plus r. Sorry, minus r. Right, so I've just taken this to the right hand side. So this is as it is, qp minus r. Right, so 2p cube equals to pq minus r. So this is the correct answer. Okay, any doubt? A similar question, if the zeros of the polynomial x cube minus 12x squared plus 44x plus c are in AP, then the value of c is. So again we'll get 3 beta, right, is equal to 12. So the value of beta will be equal to 4. The same way, right? So now we just need to substitute 4 here. So 4 4s are 16 and then 16 4s are 64 minus what is the value of 12 times 16? So 12 6 are 72. So 192. And then what is the value of 44 times 12? So we'll get sorry, 44 times 4, right? Because 4 was the root. So 44 times 4, 4 4s are 16, 176, right? So we get this as 0, right? So 176 plus 64 is 6 plus 4 is 10, and then 7 plus 6 is 13, so 14, and then 240 minus 192, right? So this will be equal to, and then we have c as well, right? Plus c. So plus c is equal to 0, right? So this will be equal to, c will be equal to minus 48, right? So D will be the correct answer. The zeros of the quadratic polynomial x square plus ax plus a, where a is not equal to 0, right? So here what you need to do is alpha plus beta, say, are the roots. Alpha and beta are the roots. So it is asking about the signs of the roots, right? So you'll just write alpha plus beta equals to minus a, and alpha beta is a, right? Now it is saying cannot both be positive or cannot both be negative. So you just have to look at or try to find the signs of alpha and beta. Say let the first case be a is greater than 0. That means sum of roots are negative and product of roots are positive. When is this possible? When both alpha and beta are negative. Right? So, I mean, this is incorrect in that case. Because it says cannot both be negative, but we have just proven that they can be negative. So when they are negative, their sum is negative and their product is positive. Right? The second scenario we can take, let a be less than 0. Which means the sum of roots are positive because minus of a, minus of negative is positive. So alpha plus beta is greater than 0 and alpha beta is less than 0. When is this possible? When they are of opposite sign and the positive sign is greater than the negative sign. That is why their sum is greater than 0, but their product is less than 0. So, I mean, this is true. They cannot both be positive at the same time. If one is positive, the other has to be negative. Right? For C and D, it says are always unequal or are always equal. So, when you have this question, are always unequal or are always equal, just calculate D. Why? Because roots are, I mean, x is equal to minus b plus minus root over d upon 2. Right? If this d is 0, then both the roots are equal. If d is not 0, then both the roots are unequal. So just find d. What is the value of d? D is a square minus 4a. Yeah, it can be 0 or it cannot be 0. So it can be 0 when a is 0. And it can be non-zero when, it can be 0 when a is 0 or 4. Not 4. Yeah, 4. Right? When a is 0 or 4. Other than this, it can be non-zero. So we cannot comment that it is always unequal because we just proved that there are two values for which the roots are equal. Right? And we also cannot say that they are always equal because there are only two possible values of a for which they are equal. Okay.